The machine had 158 quintillion possible settings. Not million, not billion, 158 quintillion. The number is so large, it barely registers as a number. It registers as a wall. And that was the point. German Naval Command was so confident in Enigma that they updated its codebooks monthly, changed its daily settings before sunrise, and wired it into every U-boat, every air wing, and every field command from Norway to North Africa. They called it unbreakable. They called it that in writing, repeatedly, in documents that still exist. They were wrong for most of the war. The British knew. The Americans knew. Joseph Stalin was briefed. And Germany, the nation that built Enigma, refined it, and staked the lives of hundreds of thousands of soldiers on its secrecy, did not find out until...
The problem Enigma was designed to solve was old. In any war, the side that can communicate faster than its enemy holds a structural advantage. By the time of the First World War, that communication ran through telegraph cables and radio signals. And radio signals travel in every direction simultaneously. Anyone with a receiver and the right frequency can hear them. The British knew this. The Germans knew this. Both sides spent the war listening to each other's traffic. The solution, traditionally, was encryption. Substitute one letter for another according to a fixed key, and the enemy intercepts gibberish instead of orders. Simple ciphers had existed since Julius Caesar. The problem with simple ciphers was equally simple. They were solvable. Given enough intercepted traffic, a patient analyst could find the statistical patterns and reconstruct the key. The Germans had done it to the British had done it to the Germans. Arthur Scherbius understood this. He was an electrical engineer, born in Frankfurt in 1878, and by 1918 he had designed a machine that would, in theory, end the problem permanently. His solution was not a better cipher. It was a machine that produced a different cipher with every single keystroke. Press the letter A once, and the circuit routes through 3 rotating wheels to produce the letter Q. Press A again immediately afterward, and the wheels have advanced by 1 position. The circuit now routes differently. A produces M. Press it a 3rd time. A produces X. The same letter, 3 different outputs. No pattern. No repetition, not for 16,900 keystrokes per wheel configuration. The Wehrmacht began adopting Enigma in 1926. By 1939, it was the backbone of German military communication across every branch of service.
To understand why Germany believed in Enigma, you need to understand what it actually did. Start with a standard typewriter. When you press a key, a single mechanical action produces a single fixed output. A is always A. The relationship between input and output never changes. Any enemy who knows that relationship can read everything you write. Now imagine modifying that typewriter so the relationship changes with every keystroke. That is the base concept of Enigma. The machine had 3 main components. The keyboard, 26 letters, no numbers, no punctuation. A plug board at the front, which physically swapped pairs of letters before anything else happened. And 3 rotors, each a disc roughly 10 centimeters across, each face wired internally to scramble any electrical signal passing through it. When an operator pressed a key, the electrical signal passed first through the plug board, which swapped, say, A for T before anything else. It then passed through all 3 rotors in sequence, each scrambling it further. It hit a reflector at the far end, which bounced it back through all 3 rotors in reverse. It hit the plug board again, and finally it lit up a lamp on the display panel showing the encrypted output letter. The critical element was the rotor advance. Every time a key was pressed, the rightmost rotor clicked forward by 1 position. When it completed a full rotation, it advanced the middle rotor. When the middle rotor completed a full rotation, it advanced the leftmost rotor. The mechanism was identical in principle to a car odometer. Each keystroke changed the internal wiring path completely. The plug board added another layer. By connecting pairs of letters with cables, the operator could define up to 10 additional letter swaps before the signal even reached the rotors. The number of possible plug board configurations alone ran into the hundreds of trillions.
The daily settings, which rotors to use, in which order, with which starting positions, and which plugboard connections, were distributed to all operators in a monthly codebook. Change the settings, and the previous day's traffic became unreadable even to your own side. On paper, it was elegant. The flaw was not in the engineering. The flaw was in the assumption behind the engineering, that a machine's theoretical unbreakability would remain theoretical unless it was actually broken. It had already been broken. Poland had done it in 1932. Germany did not know.
The Polish Cipher Bureau broke the first version of Enigma using mathematics. Marian Rijewski was 27 years old in 1932 when he was handed a problem his superiors believed was unsolvable. He was a mathematician, not a linguist, not a soldier, and not an engineer. He approached Enigma not as a machine, but as a mathematical object, a series of permutations that, under the right analytical framework, had structure. He found it. Working with a German codebook that French intelligence had obtained through a source inside German signals intelligence, Rijewski reconstructed the internal wiring of the Enigma rotors from captured traffic alone. By 1938, the Cipher Bureau had built mechanical devices, called bombs, that could systematically test possible Enigma settings and find the daily key within hours. In July 1939, 6 weeks before Germany invaded Poland, Polish intelligence handed their complete Enigma analysis to British and French counterparts. They handed over their reconstructed machines. They handed over 7 years of cryptanalytic work. Britain's government code and cipher school received it at Bletchley Park. What followed was not a clean intelligence triumph. It was a 9-year bureaucratic and scientific struggle that the official history classified for 30 years after the war ended. Alan Turing arrived at Bletchley in September 1939. He built on Rijewski's bomb design, improving it systematically until British machines could crack daily Enigma settings, when conditions were right, within hours of sunrise. By 1941, Bletchley was reading significant portions of Luftwaffe and Army Enigma traffic in near real time. The German Navy was harder. Naval Enigma used an additional fourth. Bletchley Park was shut down after the war. The staff were told to say nothing. The machines were destroyed or dismantled. The files were classified. Churchill called the Bletchley analysts his geese that laid the golden eggs and never cackled. He meant it as a compliment. It was also an instruction. The existence of Ultra was not officially acknowledged until 1974, when historian Frederick Winterbotham published The Ultra Secret. By then, most of the people who had done the work were in their 50s and 60s. Some had died without ever telling their families what they had spent the war doing. Alan Turing received no public recognition during his lifetime. He was prosecuted by the British government in 1952 for homosexuality, subjected to chemical castration as an alternative to prison, and died in 1954. His contribution to the Allied war effort remained classified. One working Enigma machine is on display at the National Museum of Computing at Bletchley Park. You can watch it encrypt a message. The rotors advance, the lamps light up, the output is unreadable. What this story actually is not a story about cryptography. It is not a story about Alan Turing or Polish mathematicians or British intelligence. Those are the people inside the story. The story is about what happens when an institution builds something it believes is perfect and then stops asking whether it still is. Germany had the question available to them for the